Hello everyone, here we are with one more example of transient structural analysis using ANSYS Workbench. Today we will see in a tutorial number 42 time dependent loading on beam and how it works in the transient structural analysis. So we have already know what is meant by transient structural analysis, but I am again repeating this particular thing. When load vary with respect to time on the structure, then it is termed as a dynamic loading. Transient structural analysis is referred as a flexible dynamic analysis. It can be used to find out the dynamic response of a structure under the action of any general time dependent load. In short, in transient structural analysis, load changes with respect to time. Here there is no constant load, the load is changing with respect to time. So the flexible dynamic analysis assures us to provide time varying displacement, strains, stresses and forces in a structure at it responds to any transient load, which means that whenever we will use this particular phenomenon transient structural analysis, our solver, ANSYS solver, give us the displacement, strains, stresses, forces which are changing with respect to time. On the other hand, when we solved the static structural analysis, the load was dead, it was not changing. That's why it is called as a static structural analysis. Transient structural analysis investigate the response of a structure under a transient load. So these are very important things which we should know. Now while solving this particular transient structural analysis thing, we have to notice, we have to give some inputs in the analysis setting. While we solve during the static structural analysis, we need not to give any the analysis setting to solve it, but here these are the few terms which we need to know: step control, number of step, time integration thing, then the step end time as well as the time steps. So all this thing we will see when we will actually solve the problem in the ANSYS Workbench. We will see whatever I will explain each and everything, don't worry. So before that, before going into that, we should know what is meant by time step. Means this is very important phenomenon. When we will solve the problem which are related to velocity or acceleration, the time step will play very important role. I will again explain this thing in the detail when we will see the explicit dynamics. In explicit dynamics, time step will play very important role, but today we will just go into the brief and I will tell you what is meant by time step. The time step is the incremental change in time for which the governing equation are being solved. Means whatever the governing equation is solving means this solver use, the time step shows the incremental change in time. Means in simple word, I will give one example. If we are considering event of 1 second, means our event means we are having any load and which we are put this load on any structure and it acting along that particular structure along for 1 second. Then what time step do? If I give the time step of 0.1, then this time step give me the answer at 0.1, 0.2, 0.3 till the end of time, till I will get the 1 second. What happened due to this? This is a time increment thing, means time integration thing, due to which the solver which solves this particular problem, it solves very fast and it gives us a result. Otherwise, if we take same thing into the explicit and we are not using the time step, then the solver will take very long time and it required very heavy hardware also. So what happened means every software has its various method to calculate the time step. While the velocity and acceleration problem arises, we will see another way to calculate the time step, but today we are going to see the transient structural analysis. We have one formula to calculate it. General suggestion for the initial time step means we'll see when I will put this initial time step thing into the while we will solve the problem of beam. Is use the following equation where the frequency response is the frequency of the highest mode of interest. So this is the formula. First we will do the model analysis. We have already seen what is meant by model analysis. Whatever the mode shape I think that particular my object is capable of or having moving, I will pick that particular frequency, multiply it by 20. 1 by that particular value is nothing but delta t. So this is the normal way of calculating the time step in the ANSYS. Guys, please don't get confused. We will see each and everything in detail. Just have patience. So time varying load, what is meant by time varying load? When the load or a joint condition, the magnitude can be defined as a constant tabular value or a function. Means here when we are adding the load, we will give the load with respect to the time. Means we will do some tabular work and we will give the time as per the time step. So this is very important. So now we'll move to the problem. See, the simply supported beam, here we are using time varying load. So consider this is the simply supported beam we have, and having the 500 mm length and having the cross section of 25 mm, we are considering it as a square. So consider these four load at four different time. First load is acting at first second load is acting at second, and then another load is acting at third second, and another load is acting at fourth second. The magnitude of the load, we will see what is the magnitude of load. Magnitude of load is 1000 Newton, means each load is of 1000 Newton, and we are considering the distance between the two loading loads is of 100 mm. So from right hand side, when we go for the first second at 100 mm, that 1000 Newton load is acting for first second. Then after some time, means after 2 seconds, there is another load of 1000 Newton. After third second, there is another load of 1000 Newton, and there is another load of 1000 Newton after 4 seconds. Means all the load which we are giving or applying on this particular beam is not at same time, it is changing with respect to time, and we will see how it get solved using the ANSYS Workbench. And using the ANSYS Workbench, we have to calculate the equivalent stress as well as the direction deflection. So let's get started, guys, with the ANSYS Workbench. We are at ANSYS Workbench, and using the ANSYS Workbench software, we will solve the transient structural analysis. So see, guys, what is the generalized method of solving the transient structural analysis in the ANSYS? Actually, in the ANSYS, first we will do the modal analysis of any particular object, and after that, according to mode shape, we pick that particular frequency. Then we will carry out that frequency to that delta t initial formula, and then we will find out the initial time step. This is the generalized methodology. Few follow this method, few don't even not follow this particular method, but as this is our first problem, so we will follow this particular method. It up to us that we have to use this particular method in the upcoming tutorial or not. So first, when we will come to the ANSYS Workbench, today we will find out that there is no property dialog box. So what we will do, we will go to the view, we'll ask for the reset workplace. After resetting the workplace, even it is not appearing, then we will go to the view and click on the properties. As soon as I will click on the property, I will get the properties of project schematic. So this is the thing which I want today actually. So now we will go to the model analysis, and in the model analysis, if we will not disturb the engineering data, we will take the same composition of the material, that is our material structure is still having the 210 gigapascal Young's modulus of elasticity, and Poisson's ratio is of 0.3. so all these things are automatically fed into this particular thing, so we need not to disturb it. When we will click on the geometry, then this particular property box gets expanded, and as we are doing the problem of beam which is very long, so we'll today we will use line bodies. We have already seen what is meant by line body. Means I don't remember the exact number of tutorial, but in my previous tutorial, I'll say tutorial number 14 or 15, we have solved the cantilever problem using the line body, so you can check that particular thing. So we have selected the line body in the geometry, and we'll double click on the geometry. So once we come to the design modeler, we will draw the beam, but today we will draw the line body. Now don't get confused what is meant by line body. Today we are using the 1D element, not we are using 2D element or 3D element. Now why we are using 1D element? Because the object is long and its cross section is comparatively small. What 1D element do? 1D element having two nodes at its two ends, if we consider first order 1D element, and due to which it only saves our time, means calculation takes place only at two nodes instead of uh, the 4 node in case of the 2D element and the 8 node in case of the 3D element. So in short, it saves our time, that's why we are using the 2D 1D element here. So now go to the XY plane, and now first what we will do, we will convert this units into the millimeter, as we have the unit in the millimeter. Now we will go to the sketching, and at sketching we will look for the lines, or rather instead of line we will select polyline. Polyline will be better, as we have to break this line into 4 parts, because we have loads at the 4 different location. So from point P I will start first, second, see the horizontal, third, fourth, and last one, fifth. And now I will give the open end. Now I will go to the dimension, and at dimension I will go to the general dimension and select all the dimension one by one, and give all 100 mm, 100 mm, 100 mm, and make this sketch fit into our window. So 100 mm distance and 4 load location is created. Now next, what we have done, first we have created the line, means we have created the length of 500 mm. Now we will go to the concept, and now go to the cross section, and at cross section select the rectangle, and we know the cross section, it is 25 mm by 25 mm, so cross section is selected. Now after the selection of cross section, you will find that still there is a 0 part and 0 body, because we haven't used the option which is required to create the 1D element or the beam element or the line body. So go to the concept and select the lines from the sketches, means we have the sketch, we have the line, we will carry that particular sketch along with that particular line. So after using this particular option, now it is asking us to select that line. So we have the line with us, so press the control button and select all lines and apply it and call for the generate. Now the line body is created. Now you will see one part body is created, and the name of that line body is means the name of that part body is line body, but yet cross section is not applied. So we have to apply this rectangular cross section and generate it. Now cross section is also provided. Now you will not able to see the beam because, as I have mentioned earlier, we are using the line body, and line body, see, this is first node and second node, so calculation directly calculated on this particular location, so it saves our time. So what we will do, actually not on this point, means we will again discretize this particular line into small parts, so that the calculation will get means calculation will get fast and we will get the accurate results. So now what we will do, to see the cross section, we will go to the view and see the cross section solid. From cross section solid you will see your cross section, but we are not going to solve the complete problem for this particular object. We are only using this particular single line on which we will calculate all the calculation, or rather as the software will calculate all the calculation and will give the accurate result. So this is the application of line body, guys. It saves our time. Now we will move to the ANSYS mechanics for the model analysis to find out the natural frequencies. Here with our particular line body, and now we will ask for the meshing. We will create the automatic mesh here. So mesh is created quickly, and see the mesh is created, but the mesh is of 1D element, not of 2D or 3D element. So now we will go to the model analysis. Here what we have to go, we have to provide only the support, and we know that this is the simply supported beam. So first fixed support appears at this point, we will apply, and next fixed support will rather I have selected fixed rotation, so another fixed support is at this particular point and applied. So we have provided the fixed support at both end. What model analysis does? Model analysis gives us the mode shape as well as the natural frequencies. You can check my model analysis YouTube means that particular video. I have performed model analysis and it is in the detail. So now we'll ask for the solution. Once we get the solution, we will go to the tabular data for this particular thing, and in the solution you will find out 6 modes are created. When we will see the tabular data, we will have total 6 mode. Actually we have solved for the 6 mode, that's why this particular thing gives us 6 mode. If we want more modes, then it will give the more modes. So all 6 modes are available with us and all frequencies available with us. I have selected complete all the frequency and I will create the mode shapes for it. So see, the 6 different mode shapes are for the total deformation created here, and I will ask for the solution. Now see guys, what we are getting from this particular thing, what we are actually looking for. We will go to the graph, we will see the modes. So if our geometry is a simply supported beam, the transverse loading, then this is the possibility that we will get this type of deflection. This is one possibility. The next possibility, it is showing like this. Okay, this is not the way that we will get the deflection. As the load are transferred, it coming from the upward direction, it will not move this particular object like this. So this is not the case. This is also not the case. In this way it will not move. This is also not the case. So it's up to you that how we can decide it. So from first mode, it is clear that our deflection will be like this. So we guess it that our deflection will be like this. So from tabular data, this frequency is 510 hertz. So now we have the formula that delta t is equals to 1 upon 20 into frequency, natural frequency. So we have the 510 hertz frequency with us, and using that formula we can calculate the delta t time. So this is the main purpose of doing the model analysis. Now we will go to the transient structural analysis for further process. Take the transient structural analysis and put it into the model. As we know that we have already solved the particular object for model analysis, and we have calculated whatever the initial time step value. So using that time step value we will solve our problem. So let's calculate what is the initial time step. The formula is delta t is equals to 1 upon 20 into frequency. So we have frequency of 510 and 1 upon that particular value. Time step arises using that particular formula is 0.000980. So remember that it is 9.8 into 10 to the power minus 5. So we have to use this particular value while solving the time step. Now you can see that transient analysis appears here, and the most important thing in complete this particular analysis is now to check the analysis setting. Now see what I will do in the analysis setting. In the previous problem, instead of time we have used sub step. Now today we will use a time the thing which we are going to use. Now number of step, it depends upon us how to solve the problem. Today we will solve the problem for 4 steps, means I will apply the loading at 4 different steps. So out of which this is the first current step. I can select the second also, which is at second. I can select the third step, which is at the third second. In this way you can see the changes here also. And at fourth step the time will be fourth second. So first we will go to the first second. Now you will find out here the initial time step. Now initial time step, whatever we have calculated is 0.1234980. so this is the initial time step, that is 9.8 into 10 to the power minus 5. But guys, now see, don't get confused actually. Whatever I will do now, please, due to that particular thing, please don't get confused. 1 second is very long period. Today we are solving the problem for 4 seconds, means in this particular dynamic loading 1 second means very long duration for anything, but we are solving for it the 4 second. The solver will take very long time, and the system will not support for this particular long calculation, because what happened, after every 9.8 into 10 to the power minus 5 calculation, the solver take that particular value, means my complete 4 second is divided into 9 means 4 second is divided into 9.8 into 10 to the power minus 5 second. Means you can see that first 4 second means how many milliseconds, and divide that particular thing by the 9.8 into 10 to the power minus 5. So in this way you will gauge that how much sub steps, means how much steps will be created, so due to which the time will be taken very long. But if we solve using this particular time step, the accuracy will be there. But today we are not going for the accuracy, as the hardware will not support this particular thing. So I will change the initial time step by 0.1. what this thing do, it will only changes the accuracy, but it will not change the course of solution method will be same. So please don't get confused that if you want to, means you may ask me that if you want to do the same method, then why use the model analysis. Guys, I just want to show you that how these things works. As I mentioned you earlier, that if you want to use this model analysis and then after the transient, you can do it, otherwise it's your choice. So I am not using this particular thing because of the software constraint. I am using my initial time step of 0.1. so due to this, what happened, my 1 second is divided into 10 part and one interval is of 0.1 second. So initial step and all these things are of 0.1 second, and step ends at first second. The current step number is 1. Now I will go for the current step number 2. That step will end at second, means second, and the time step will be of 0.1 and 0.1. Then I will go to the third time step, or rather third current step, and this is 0.1 and this is 0.1. Then I will go to the fourth step, enter the time step value 0.1 and 0.1. In simple word, I am again repeating that my 1 second is divided by 0.1, then I will get the value of 10, means my 1 second is divided into 10 parts. So calculation will, after 0.1 second calculation gets stopped. We are just exaggerating the thing. After 0.1 second calculation gets stopped, it gives me the value. Then again after 0.1 second it gets stopped. So in this way my calculation get forwarded. This is known as time integration thing. So we have used 4-step thing for different steps, and the step end time is also different. So in this way we have created the analysis setting, and you will see the green check mark here. Now we will apply the boundary condition, fixed support for this end, as this is the simply supported beam. Then again fixed support for this end. Okay, now we have applied the fixed support. Now it time to give the loading. Now go to the insert and go to the force. At first of all, force, we have to select the location of the force. So we will start from the right end, and the first location will be our first point. So this is the first point, which is 100 mm from the right hand side. So we have selected that point and we have applied it, and instead of vector we are using the component. Now what we are going to do, see, this is the z direction. Okay, so we have to apply the load along the negative z direction. So in negative z direction, when we want to apply the load, we will go to the z component and will go to the tabular data. When we will go to the tabular data, you will find that there are 4 steps and there are 4 different seconds. We will uncheck the x and y direction. We don't want to go for the x and y direction, and we will go for the z. So we are where we are. First we will go to the analysis setting. From analysis setting, I am at current step number 1. So at current step number 1, this force is applied of minus 100. So as soon as I have give the minus 100, all this particular table gets cell get filled with the minus 100. But guys, I don't want the load at the second on this particular point. So I don't want the load in the third second at this particular point, neither I don't want the load at this particular point at the 4th second, even at the 0th second. I want load at this point only first second, and after second there will be no load at this particular point, only 100 Newton will be there, and after third and fourth also there will be only 100 Newton. Sorry, 100 not 100, we are actually dealing with the minus 1000 Newton. So only minus 1000 Newton load at first second. Whereas if I am talking about the second, there will be no load at this particular point because the load is already acted at the first second. Third and fourth will remain also empty. Now I will go to the force. I will duplicate it. Go to the analysis setting. Now I will go to the initial current step number 2, and at force, here we have the tabular data. I will put minus 1000 Newton. But what happened here, guys? I haven't selected the location yet. So this is the first point, but second point is appeared here. So I have to select this particular point, not that point. So minus 1000 Newton at the second. So rest of the thing is 0. And minus 1000 Newton is applied at the second at this second location. So force 2 is applied. Now again I will go to the duplicate, and into the analysis setting I will go for the third step, into the force 3. What first I will do, I will select the location. This is the third location. I have applied this particular location, and at third second this is the minus 1000 Newton, and for this particular point during the second the load is 0. So this particular load is acting on this point only at third second. First second and second for this location there will be no load. Even for the fourth second there will be no load at this particular location. So again I will duplicate this particular object force, and again I will go to the analysis setting, change it to the fourth step. Then I will go to the force 4. I will make it is 0, and the location, rather I will put the minus 1000 Newton here, but the location is not same. Location is here. So location is changed, and here I got the fourth force, means fourth location. So in this way I have the 4 force here at different 4 time step. So if you want to see the graph, you will see the changes. First at first second at this location you will get the load, then force 2 second location, then force 3 third second, and force 4 is here. So you can see the changes, first 2 3 and 4. If you want to see the arrow at every location, then you have to change this analysis setting. You have to put the 1 2 3 4 here. You will see that particular arrow. Now see guys, this is known, this particular graph shows us the dynamic loading. So this is very important way to understand how this particular dynamic loading is actually given on this particular points. So force 1, force 2, force 3, force 4 is provided, fixed support is also provided. Now we will ask for the solution, and solution will take some time. Now once we have this solution, now we will ask for some results. First we will see the deflection of beam. The deformation, we want directional deformation, and we want in a Z direction. And next thing, we want stresses. Now you will find that there is no von Mises stresses is provided here, because we are using the line body, so it is directly providing us the beam tool. It calculates the all possible stresses which can occurs on the beam. So beam tool is directly provided. So beam tool provides us the direct stress, minimum combined stress, and maximum combined stress. So this is a quite useful tool which is provided in the ANSYS. And now we'll ask for the solution. And now once we get the solution, we will see the directional deformation first. We will adjust the scale. So this is very useful. And now see the directional deformation. The maximum directional deformation is minus 0.09 mm in a negative direction. It shows the location as well, and the minimum is 0, which is at the support, which we know that at support there will be no deflection of the beam. Now important thing is that this particular beam is showing such deflection because the load is changing with respect to time, and the location is also different. Load is not at one place, it is distributed in 4 location, and the time is different. First occur on the first second, and the last one at the 4 seconds. So that's why you can see the difference in the result as well. Whereas in the beam tool, if you go to the direct stresses, you will find that the direct stresses is provided. We'll see the maximum combined stresses. In maximum combined stresses, it is showing 24 megapascal is the maximum, which is acting at the support, and around 0 megapascal is minimum. So using this particular option, we will see how the stresses value can vary. Maximum is at the support, which we can see. Even you can draw shear force diagram and the bending moment diagram also. You can check my previous video for this, how to draw this shear force and bending moment diagram. So what we have learned from this particular tutorial is that how to apply the load with respect to time at various location of any object. Means using this concept, we can solve any problem. Means whether it is beam or whether it is any machine element, we can solve it by using same process. So next tutorial we will see another example of transient structural analysis. Till then, keep watching my channel and subscribe it. Thank you very much.